Hello grade 10, good day. Welcome in today's episode of IS TV. This is your teacher Mar and I will be here to give you mathematics techniques to simplify your lessons in mathematics. I will also help you in developing your mathematics literacy, logical reasoning, and critical thinking skills. Is your module ready? How about your pen and paper? Great! Let's begin a fun and exciting lesson. When a man was on his way home from Tagaytay City, he came across the beautiful town of Amadeo, which is considered as the coffee capital of the Philippines. He suddenly felt longing to the taste of delicious coffee. He stopped at the well-known Cafe Amadeo and ordered a cup of coffee. "Oh, the coffee is really delicious," a man said to himself. Look at the picture of coffee beans. What can you say about the arrangement of the beans or the fruits? You are right. The beans seems attached in an orderly way. How many beans are there in the first group? Correct. There are 4 beans. In the second group, did you count it 6? Very good. How about in the last group? Yes, there are 8 beans. If the pattern continues, how many beans are attached in the next group? Amazing! There are 10 beans. It only shows that we can see many things that show different patterns in our environment. So, if there is a pattern, there is a sequence. For this lesson, you are going to learn how to generate patterns from a given succession of objects, numbers, letters, and symbols. The word sequence means an order in which one thing follows another in succession. A sequence is an ordered list. For example, if we write x, 3x, 5x, 7x, 9x, and blank, what would the next term in the sequence be? The correct answer is 11x. A sequence is a set of objects which is listed in a specific order, one after another. Each member or element in the sequence called term. The terms in the sequence can be written as a sub 1, a sub 2, a sub 3, a sub 4, up to a sub n, and so on. Which means a sub 1 is the first term, a sub 2 is the second term, a sub 3 is the third term, up to a sub n is the nth term, and so on. Sequences are classified as finite and infinite. A finite sequence contains a limited number of terms. This means it has an end or a last term. Let us consider these examples. Positive example 1. Months in a year, we have January, February, March, April, and up to December. For letter B, the first 5 positive multiples of 3 are 3, 6, 9, 12, and 15. So those are examples of finite sequence. On the other hand, an infinite sequence contains a countless number of terms. The number of terms of the sequence continues without stopping or it has no end term. The ellipses or the 3 dots at the end of the following examples shows that the sequences are infinite. Let us consider the examples. Positive example number 3, or letter A, perfect squares. 1, 4, 9, 16, 25, 36, 49, and so on. Or letter D, Fibonacci sequence. 1, 1, 2, 3, 5, 8, 13, 21, and so on. But we are going to discuss Fibonacci sequence thoroughly in the following weeks. Sometimes a pattern in the sequence can be obtained and the sequences can be written using a general term. Now, let's try finding several terms of a sequence given the general term. Are you ready? Let's start with the first example. Illustrative example number 4. Find the first 4 terms of the sequence a sub n is equal to 3n minus 1. The first term, let us substitute n by 1. So we have a sub n equals 3n minus 1. Then substitute n by 1. So we have 3 times 1 minus 1. Then multiply and simplify. So 3 times 1 is 3 minus 1. So therefore, a sub 1 is equal to 2. To find a sub 2, we need to substitute n by 2. So a sub 2 equals 3 times 2 minus 1. Then let us simplify. 3 times 2 is equal to 6. Subtract it by 1. Then a sub 2 is equal to 5. To find a sub 3, substitute n by 3. So a sub 3 equals 3 times this n becomes 3 minus 1. Then let us simplify. 3 times 3 is 9. Subtracted by 1. Therefore, a sub 3 is equal to 8. Then, to find a sub 4, we are going to substitute n by 4. So, therefore, a sub 4 is equal to 3 times 4 minus 1. Then, let us multiply. 3 times 4 is 12 minus 1. We have 11. So, a sub 4 is equal to 11. So, therefore, the first 4 terms of the sequence is 2, 5, 8, and 11. For the mathematical techniques, let us substitute n by 1. So what is 3 times 1? So that is 3, right? Minus 1 equals 2. Therefore, the first term is equal to 2. So since we have 3n or 3 times n, the technique here is just add 3 on 2. So we have 5. And then add 3 on 5, we have 8. And add 3 on 8, we have 11. So therefore, the first 4 terms are 2, 5, 8, and 11. So a sub n is equal to 4 and suppose a plus 2. So let us just get the first term. 4 times 1 is 4, right? Plus 2 is equal to 6. Next, just add 4. 4 plus 6 is equal to 10. Then 10 plus 4 is equal to 14. 14 plus 4 is equal to 18. So I hope everything's clear. Let us see if you learned from this episode. Kindly answer the following questions. Great job! Now, let's check your answers. What's your score? Congratulations still. I know you can do better next time. I guess you've learned so much from our lesson for today. On the next episode, you're going to learn how to illustrate arithmetic sequence. Once again, this is your teacher Mark. Always remember that we will find mathematical techniques in simplifying your math lessons, and it will always be easy. Only here on IS TV.